today we are going to see the new lead code problem, that is count vowel permutation. So you have been given an integer number n, let's say that is 1, then you have to create the string of length n. So let's say it is n equal to 2, then you have to create the permutations of length 2, but you have to satisfy these given condition. One condition is each character is a lowercase vowel, that is from a, e, I, o, u. Okay, so it says second condition is each vowel a may only be followed by an e. So if the previous vowel is a, then you can only have e at the next position, and that is the condition, you can say. So, and now you have to construct the possible strings, not construct, you have to just calculate the count. So let's see. First let's paste this condition. Okay, just remove it. So I can say you can use a, e, I, o, u. So first if you put a, then you can only put e here. That is the only combination for a. And if your character start from e, now you have some condition, that is it can followed by a or I. So either it can be e a or either it can be e or I. And for I, that should not be followed by I. So you can say I a is possible, I e is possible, I is not possible, I o is possible, I u is possible. So you can say here it is based on the character that we have put, and the next character is based on what we have put on the previous character, you can say. So let's say, or for AE, the next would be AEA or AEI. You can see, because after E you can only put A and I. So I think this is the straightforward questions. So I don't think it is a hard level question. I don't agree with that. So I will just quickly go through the approach. So first of all, I will start from A, and then after A we can just put E, and once we put E we can just follow E, AEI or AEU, because after E you can see you can follow A and I. Okay, so A and I, and then we will start from E. For E we can have EA, we can have EI, and now after EA we can have after EAE. For EI we have EIA and EIE, EIO, EIU. And once we reach the length, that is n equals to 3, let's say, we will return that is the one combination. For every combination we can say it is the number 1 plus 1 combination, and AEIOU, and we can just do these things recursively. So let's jump to the code. So one more thing that we can observe here is, if we have calculated the number of combination for AE, we can also predict the behavior based on this one. So this is the, you can say it is a sub problem. So we may have calculated IA here, so we don't need to recursively go through all these things. Let's jump toward the code. So first of all, I am creating mapping. So okay, so I am calling A as 0. I am denoting A, E, I, O, U as 0, 1, 2, 3 and 4. So you can say from A you can go E. So I can say from 0 you can go 1. So this is the mapping I am constructing. So this is the mapping 0 to, you can go, 1 second, let me retrieve last submitted code. Yes, 0 to 1, then 1 to 0 to, that is the mapping I am creating. After that I have initialized the DP. Let's just forget this for time being. I will tell you like why we are doing this. And after that we are going through each character for length 1, and then we are calling the helper function. What it will do, it will just iterate all the adjacent element, that is you can go 0 to 1 and you can go 1 to 0 to, and it will do like that. And once you reach the end, you can say this is the one combination, and we are sure about that. And I think that's all. And if I run this code, it will give me the TLE. You can see here it just gave me TLE. Initially I have used A, I, O, U, these things, and I just got TLE. And after that my second submission was this one, where I have applied DP, dynamic programming, on the array, because in this function what is changing, you can see only I and X, these two things are just changing. So I have created one 2D array and I am just storing these things into that. So if that is not -1, means I have already calculated that combination and I am just returning it. So this is the same thing. I'm just here using the 256. Why? Because AEIOU can be I can directly use as an index, that's why. After that I got 64 ms runtime, so I try to further optimize it, and let's say that is 46 one. So what I have done here, I have connected a, e, I, o, u into a corresponding index that will reduce my array as well, and some time complexity as well, you can see. And you can see overall the logic is the same, always the logic would be same. Okay, so this time I got 46 ms runtime, and I have also optimized some memory as well. Then I have another solution where what I have done is unnecessarily doing the mode operation. So initially I was doing mode here as well, here as well, here as well, here as well. So I just removed all those mode operation, and that also optimize the solution a little bit. After that I have 32 ms solution, 32 ms solution that is converting the long array into integer array, because that is always in the range of integer. So you can see here I have just used all the integer variables, so that would optimize the space as well and the runtime complexity as well. So I think that's the solution for all those things. And the question is straightforward. You can start from a, then e, then I, o, u, and now you know you have mapping between a and e. You can see after a you just put e. Okay, after e you just put a, and you have just loop here. You can see we have loop here. Here we have loop to go through all the mapped element. And now if I go to I have ia, I have ie, io, and iu, and this will keep on going, and then o, and then u. So that is the length of 2, you can see, and that is of length 1. And in the third layer you can see you will just add a, and after e you can add a, then you can also add, let's say, I as well. So that's how you will construct the possible length, possible combination of length and length, you can say. And every time you just increase your answer by +1, and that would be your final answer. So I think that is pretty much optimized solution, but not that much optimized. I have another approach around that. So let's say, and I didn't have code for that. So let's say that is count of a, that is count of e, and o, u. Initially we can see of length 1, that would be 1 and 1. Now if I want to pick a for the length 2, then I know that a can be occurred by e as well, and let's say a can be occurred by e, a can be occurred by u, a can be occurred by I. So 3 combination are there, which are e, I, and u. E, I, and u. E, I, and u. I can add all these 3, and I can say now for length 3, that ending from a, that would be 3. Why? Because e is one combination, I a is one combination, u a is one combination. One second. From a I can say a can come from ea, ia, and ua. So I can say that would be count of 3. Now come to e. For e as well, you can say you can come from a. Okay, and but here we need to make sure that for length 2 we are not updating this array. Okay, so once we update here, like you say we are coming from a, and now it is 3, but it is not 3. For length 1 it is still 1. Now updated 3 is for the length 2. So if you want to know the previous length, that is still in this array. So this is one more approach, you can say, where you can solve the problem using this approach as well. So yeah, that's it. Thanks.